Dear students, very good afternoon. Now we are going to discuss one important problem, that is, take the question first. The problem today we are going to see is find the analytic function f of z equal to u plus iv given that first problem, given that minus 2v equal to e power x cos y minus sin y, e power x cos y minus sin y. Okay, so this is the problem they have given. So now for this term minus 2v equal to the function of x and y, we have to construct an analytic function f of z equal to u plus iv. So how to construct that is what we are going to discuss now. So here comes the solution. Always we have to take the first step as f of z equal to u plus iv. Okay, now you have to see, we have to get minus 2v. So you have to keep that in mind. So this is our equation number 1. What will be our equation 2 is, we have to multiply entire equation by I into f of z equal to I u minus v. This is our equation 2. Now think, what we have to get? We have to get minus 2v. And so how to get that minus 2v? Now I am going to multiply the second equation by 2. Okay, second equation by 2. So what will I get? Equation 2 multiplied by 2 implies 2i f of z equal to 2i u minus 2v. Okay, 2i f of z equal to, so it is this nothing but 2i f of z equal to minus 2v plus I into 2u. Okay, I into 2u. Okay, now what they have given? They have given minus 2v equal to e power x cos y minus sin y. E power x cos y minus sin y. See, here we are having capital f of z equal to capital U plus I into capital V, whereas capital U equal to minus 2V, capital V equal to 2u and capital f of z equal to 2i f of z. 2i f of z. Now what is given? Now what is given? Minus 2v is given. So which means u is given. Which means u is given. Okay. So u equal to minus 2v equal to e power x into cos y minus sin y. So this is our u of x comma y, that is equal to e power x cos y minus sin y. Now after this, what we have to find? After this we have to find u x of x comma y. Okay, now we are going to find u, capital U x of x comma y, that is we are going to differentiate in respect to x. So here it is in the form of uv. So uv dash plus vu dash will be the result of the differentiation of ux. So u v dash will become 0. uv dash, okay, plus vu dash. vu dash is the same term, e power x into, okay, e power x into cos y minus sin y. Now here uy of x comma y, that is equal to, now we are going to differentiate in respect to y. So here also we are going to take e power x and cos minus sin y as uv form. So we get uv dash means e power x into the differentiation of cos y is sin y minus cos y uv dash, then plus vu dash, that will become 0. That will become 0. Cos y minus sin y of 0. So this is our ux and this is our uy. This ux is called as phi 1 of x comma y, and this uy is called as phi 2 of x comma y. Okay, now we have to replace x by z and y by 0. So we get phi 1 of z comma 0 equal to, this term will become 0, only this term will exist. So we get e power z into cos 0 minus sin 0. Here phi 2 of z comma 0 equal to e power z, okay, the second term will become 0, the only first term will exist, e power z into minus sin 0 minus cos 0. Okay, so phi 1 of z comma 0 equal to e power z, the value of cos 0 is 1 minus 0. Here phi 2 of z comma 0 equal to e power z into minus 0, value of sin 0 is 0 minus cos 0 is 1. So this is phi 1 of z comma 0 equal to e power z, and phi 2 of z comma 0 equal to minus a power z. So by using Millan-Thomson method, by using Millan-Thomson method, what will be the formula when u is given? When u is given, we will have f of z equal to integral phi 1 of z comma 0, okay, phi 1 of z comma 0 dz minus I into integral phi 2 of z comma 0 dz, phi 2 of z comma 0 dz, okay, 2 z comma 0 dz. So here what is phi 1 of z comma 0? Phi, it is actually capital F of z, okay, it is capital F of z. So capital F of z equal to phi 1 of z comma 0 is a power z dz integral minus I into integral phi 2 is minus a power z dz. So this minus will become plus, so it will be a power z dz plus I into integral e power z dz. So integration of a power z with respect to z is a power z itself plus I into a power z, then you will have a constant, but however we are going to write a constant at last for small f of z, so there is no need to write separately here. If you want, we can write c1 plus c or c1, whatever it is we can write. So but we can take e power z commonly here, e power z commonly here, so we will have 1 plus I. This is our capital F of z. Actually what we are having for capital F of z, for capital F of z we are having 2i small f of z, 2i into small f of z, okay, capital F of z equal to capital F of z equal to 2i into small f of z. So small f of z equal to 1 by 2i of capital F of z, that is e power z, okay, first we shall write capital F of z and then we shall write 1 divided by 2i into e power z into 1 plus I, a power z into 1 plus I. So we are going to take a conjugate multiple for this term. We are going to take a conjugate multiple for this term. Okay, so I am going to multiply this term by minus I on both sides of the division, that is on numerator by denominator, that is equal to 1 by 2i into minus I by minus I into 1 plus I of e power z. So we will have 1 by 2 of minus I into 1 is minus I into minus I is minus I squared is plus 1. So 1 minus I into e power z divided by I into minus I is plus 1. So into 1. This is our small f of z. So we can write our final answer here. F of z equal to 1 divided by 2 of 1 minus I into e power z plus a constant. Here you will have a constant c1, but finally you will have small f of z equal to 1 by 2 of 1 minus I into e power z plus constant. Okay, so this is such a important problem. I hope you all understood the problem. Thank you all for watching this video. Thank you all once again.